Mount St. Helens.
At Mount St. Helens.
Mount St. Helens.
Mount St. Helens.
So when Mount St. Helens woke up in the spring of 1980, it was too good to be true. I could hardly believe that it was really happening.
Mount St. Helens has seen an increase in earthquake activity with nearly 350 quakes over the last several months.
Mount St. Helens, a volcano located in Washington state, remains a subject of both scientific scrutiny and public concern due to its violent history and ongoing signs of volcanic activity. The infamous 1980 eruption stands as a monumental event in the annals of geological disasters. It not only caused catastrophic destruction, but also revolutionized the way scientists approach volcanic prediction and monitoring. The lead up to that eruption included several warning signs: earthquakes, minor steam eruptions, and an alarming bulge on the mountain's north face. These signs indicated a significant internal pressure buildup, which culminated in one of the most powerful and unexpected geological events in North American history. At 8:32 a.m. on May 18th, a 5.1 magnitude earthquake initiated the collapse of the entire north slope of the mountain. What followed was a lateral blast of ash, rock, and superheated gas that swept across the landscape at supersonic speeds. Entire forests were razed instantly, snow and ice melted to feed catastrophic mudflows, and an enormous ash cloud rose into the atmosphere, eventually impacting several states and parts of Canada. The aftermath offered an unprecedented opportunity for volcanologists to collect data on a wide scale. Prior to this event, the understanding of how volcanoes behave under pressure was more theoretical than practical. The detailed study of Mount St. Helens allowed researchers to correlate surface changes with subterranean magma movements. Instruments recorded how the ground swelled as magma pushed upward, enabling future predictions of eruptions based on similar observations. The importance of this eruption transcends its immediate devastation because it fundamentally altered volcanic risk assessment methods. Scientists began to refine their models, adding ground deformation and gas emissions to the range of eruption indicators. These findings have since been applied globally, significantly improving the safety of communities living near active volcanic zones. Though it has not experienced an eruption on the same scale since, Mount St. Helens has not remained dormant. Between 2004 and 2008, a series of smaller eruptions occurred that gradually built up new lava domes within the crater formed by the 1980 blast. These events were quieter, yet they confirmed that the volcano remains very much alive. Monitoring efforts have not diminished since then. Seismic instruments, GPS systems, and gas sensors are used continually to detect early warning signs. The level of sophistication in volcanic monitoring is directly tied to the data and lessons gathered during the Mount St. Helens eruption. Helens catastrophe, showcasing its lasting influence on geology and public safety policy. Understanding the threat posed by Mount St. Helens requires a deep dive into its geological structure. It is classified as a stratovolcano, meaning it is composed of alternating layers of lava, ash, and rock fragments from previous eruptions. This construction lends it the classic cone shape often associated with volcanoes, but also indicates a complex and turbulent history beneath the surface. Deep inside the earth below the mountain lies a dynamic magma chamber. When enough pressure builds, the magma seeks an outlet, often resulting in eruptions of varying intensity. Sometimes these eruptions produce slow-moving lava flows, but other times they release explosive energy in the form of pyroclastic flows and ash plumes. The unpredictable nature of these events adds another layer of danger. Among the most terrifying features of Mount St. Helens are its pyroclastic flows. These fast-moving clouds of searing gas, ash, and volcanic debris can travel at highway speeds and incinerate or obliterate everything in their path. The 1980 eruption demonstrated just how lethal they can be, laying waste to miles of forest and dramatically altering the landscape. These flows are not only immediate threats to life and property, but also pose extended risks. Volcanic ash released into the atmosphere can affect air quality and visibility for thousands of miles. Modern air travel, highly dependent on jet engines, is particularly vulnerable to volcanic ash, which can cause engine failure. Although the 1980 eruption occurred before global air traffic became as extensive as it is today, it highlighted the need for aviation authorities to take volcanic activity into account when planning routes and safety protocols. Beyond pyroclastic flows, volcanic mudflows known as lahars present another grave danger. These mudflows form when volcanic activity rapidly melts snow and glaciers, sending torrents of water mixed with rock and debris down river valleys. During the 1980 event, lahars devastated multiple communities, damaged infrastructure, and flowed as far as the Columbia River over 50 miles away. Unlike pyroclastic flows, which generally stay close to the volcano, lahars can travel great distances, often affecting areas far from the eruption site. Their sheer force and speed make them especially dangerous. Engineers and planners in volcanic regions now incorporate lahar pathways into land use maps, trying to mitigate the damage in future events. The environmental aftermath of the 1980 eruption also provides important insights into ecological resilience and vulnerability. The blast zone extended over 230 square miles, leaving an eerie moonscape where vibrant forest had once stood. Spirit Lake, once a tranquil body of water, was drastically transformed as the landslide altered its elevation and filled it with debris. Even now, floating logs, remnants of obliterated forests, cover parts of the lake. While some areas have shown remarkable signs of regeneration, others remain barren, stark reminders of nature's destructive capacity. Scientists have closely observed this gradual recovery, using it as a living laboratory to study succession and ecosystem dynamics. The regeneration process, though slow, offers hope and valuable ecological lessons. Even as the landscape recovers, the risk from Mount St. Helens has not disappeared. Seismic activity continues beneath the mountain, with hundreds of minor earthquakes recorded annually. These tremors suggest that magma is still active deep within the earth, slowly building pressure. The key question facing scientists and emergency planners is not whether the volcano will erupt again, but when and how severe that eruption will be. Historical patterns combined with new data suggest that a major eruption could occur within our lifetimes. Communities in the Pacific Northwest are well aware of the risks, and regular drills and education efforts aim to prepare residents for potential disasters. A particularly intriguing scientific debate concerns the possibility of volcanic triggering, the notion that one volcano's eruption could stimulate activity in nearby systems. Given that Mount St. Helens is part of the Cascade Range, which includes other potentially active volcanoes like Mount Hood, Mount Rainier, and Mount Adams, the idea is not entirely implausible. In theory, the redistribution of stress in the Earth's crust following a significant eruption could influence other volcanoes. However, while minor increases in seismic activity have been observed regionally after eruptions, conclusive evidence of one volcano directly causing another to erupt remains elusive. Most volcanoes, even those in close proximity, operate on independent systems. Nevertheless, the allure of interconnected geological events has led some to speculate on whether a major eruption at Mount St. Helens could influence activity at the Yellowstone supervolcano. Yellowstone, located over 500 miles away, is driven by a mantle plume, not by the subduction processes that fuel Mount St. Helens. While both are capable of immense destruction, their geological mechanisms are fundamentally different. Scientists assert that no direct link exists between the two systems, and stress or seismic waves from a Mount St. Helens eruption are unlikely to influence Yellowstone in any meaningful way. Still, the very idea has captured public imagination, prompting documentaries, speculative fiction, and debate. The distinctiveness of Mount St. Helens lies in its combination of proximity to population centers, history of explosive activity, and the wealth of scientific data it has generated. Each small eruption or burst of steam is not merely an event, but a signal, part of a larger pattern that scientists scrutinize carefully. Advanced satellite monitoring allows researchers to detect minute changes in elevation and temperature, indicating shifts in magma movement. Infrasound sensors detect low-frequency sound waves imperceptible to the human ear, but characteristic of volcanic activity. Together, these technologies form a robust early warning system, though they are not foolproof. Preparation is key to minimizing the impact of future eruptions. Emergency management agencies collaborate closely with geologists, local governments, and federal organizations to create evacuation plans, distribute public information, and maintain infrastructure resilient to volcanic hazards. Evacuation routes are regularly updated, and simulations help authorities test their readiness. The National Volcanic Early Warning System plays a central role in coordinating these efforts. Its focus on interagency collaboration ensures that when Mount St. Helens does erupt again, the region will be better prepared than it was in 1980. The human element in this story cannot be overstated. In 1980, 57 people lost their lives, many because they were in the designated safe zone that proved tragically inadequate. Among them was Harry R. Truman, a lodge owner who refused to evacuate. Their stories are part of the larger narrative of Mount St. Helens, stories of risk, denial, tragedy, and resilience. Today, education campaigns emphasize the need to take evacuation orders seriously, using historical examples to drive the point home. Schools incorporate volcano science into curricula, ensuring that the next generation grows up with a better understanding of the forces shaping their environment. Global interest in Mount St. Helens continues, not just because of its dramatic past, but because it serves as a microcosm of volcanic risk management worldwide. Nations with active volcanoes, from Indonesia to Italy to Chile, study Mount St. Helens to glean insights applicable to their own volatile regions. International collaboration in volcanic research has grown in part because of what was learned in 1980. 1980. Data sharing, joint expeditions, and global monitoring networks owe much to the benchmark set by research efforts following that event. The resilience of the natural world around the volcano has also become a symbol of recovery. Lupines and other pioneer species were among the first to return, breaking through the ash and forming the foundation for future plant and animal life. Insects, birds, and small mammals followed, re-establishing themselves in a transformed environment. Over time, ecological succession has turned portions of the once barren blast zone into meadows and young forests. The U.S. Forest Service manages the Mount St. Helens National Volcanic Monument to preserve this recovery while allowing for scientific study and controlled public access. Despite all this, the mountain remains a threat that demands respect. Its sheer power has already rewritten history once, and its activity shows no signs of ceasing. Each tremor, each plume, each new lava dome is a chapter in a continuing story, one that blends natural wonder, scientific inquiry, and human caution. The legacy of Mount St. Helens is not just a cautionary tale, but a blueprint for preparedness and a testament to the importance of listening to the Earth's subtle warnings. Whether it erupts tomorrow or decades from now, the world will be watching, learning, and hopefully ready to respond with wisdom forged from experience.